Good morning, everybody. I'd like to start class today with a little bit of an overview of what this upcoming schedule is for the next few classes and activities. First of all, of course, we had the midterm exam on Wednesday. I'm about halfway through grading those exam problems, and I plan to finish grading the midterms tomorrow sometime. So look for your graded work on the midterm to be emailed back to you by sometime tomorrow. Also on Monday, I'll be showing my solutions to the midterm exam problems. Today, we're starting a new unit. We're beginning the discussion of a very important concept in Java programming, the concept of objects. And over the next few lectures, we're going to be taking you through the basics of working with objects and showing a number of examples. The lab next week is still going to be focused on arrays. In the lecture on Monday, I talked about multidimensional arrays, and the lab coming up next week is actually going to be dealing with multidimensional arrays. So again, in that lab, you'll have an opportunity to practice writing loops, to work with arrays. Again, we're going to have ongoing practice in writing methods and using methods, and that will be the subject of next week's lab. And then the week after next, we will start the first of a series of labs that focus on this very important concept of objects. All right, so for a little while here, there's going to be a little bit of a lag. There's going to be a little bit of a separation between what I'm talking about in the lectures and what we're doing in the lab. Eventually, the labs will get caught back up, and we'll start dealing with concepts that I'm starting to talk about today. All right, so today we're going to be introducing an important new concept. We're going to be talking about objects in Java programming. The first of the chapters in the book that deal with object-oriented programming is chapter 9. So if you look at the lecture notes for today, you'll see that I have some suggested reading for you from chapter 9. And also today I'm going to be showing a couple of example projects, and at the top of the lecture notes are buttons where you can download the full code for those example projects. All right, so without further ado, let's go into the first example that I want to show today. And before I actually show you that first example, I want to start by showing you a program that we looked at on Monday, because I'd like to use this program as motivation to introduce some of the concepts that we're going to be covering today. The example that I want to remind you about is the closest points example that we did on Monday. The technique that we used to solve that problem on Monday was to use a two-dimensional array. And the reason we had to use a two-dimensional array is that the data for the problem looks something like this. This is basically coordinates for 1,000 points in the plane. And because we're dealing in a two-dimensional plane here, each point has both an x coordinate and a y coordinate. So one way that you could potentially arrange all of this data in a program is to use a two-dimensional array. So in fact, the very first method in this program is a method that will read all of these points from the data file and put them into a two-dimensional array of doubles. And here also in this method, you'll see the code for creating that two-dimensional array. And then, as always, what we have is a loop that goes through the file, reading the x and y coordinates of each one of these points and storing all of these things into a two-dimensional array. Right, so this is certainly one valid way to approach organizing the data in the application and managing the data for this application. Since you have 1,000 things and each thing is basically a combination of an x and a y value, putting all of this into a two-dimensional array is one very valid way to organize the data for this application. All right, now what we're going to look at next is the first of our examples dealing with objects. And in this next example, we're basically going to rewrite the closest points program, and we're going to be using a slightly different approach to organize the data. So let me open up that next example and show you the key parts of how we're going to organize the data. The first new thing that we're going to be doing is we're going to be introducing a class for the express purpose of doing object-oriented programming. All right. Now, it's maybe a little bit confusing because up until this point, anytime we have written a program, we've always had to create a class. But up until this point, the only reason that we have created classes is basically to serve as containers for methods. Um, every class that we've written so far has a main method in it. And if we need additional methods, we would also put additional methods into that class. So up until this point, the only type of classes we've seen are classes that basically serve as containers for collections of methods, a main method and any other methods that we need to write. Right, well, it turns out that is not the primary use of this class concept in Java programming. Instead, the primary use of the class concept in Java programming is closer to what we see here in this example. What I'm about to do here is I'm about to create a class that is designed to represent a particular kind of data that I'm planning to work with in this program. And since this is a problem about closest points, what I'm going to do is I'm going to create a class whose primary purpose is to represent a point. And then eventually when we write our closest point program, what we're going to be doing is we're going to be making arrays of these points, and we're going to be working with and manipulating those things. Okay, now right away when you look at this example, you're going to notice a number of very obvious differences that set this apart from what we've seen before. The first obvious difference you're going to see here is that there is no main method. And that's intentional because in this application of the class concept in Java, not every class necessarily needs to have a main method. You can very frequently write classes that serve other purposes other than simply acting as a container for a main method. The other thing that's completely new in this example is the presence of these special variables. These variables are what are known as member variables, and they will play a very important role in working with classes going forward. And the first thing to notice about these variables and what sort of makes them special and sets them apart from other variables we've seen before is up until this point, all of the variables that we have seen have appeared within the context of some method. For example, when you write a program, you start by writing a main method, and in your main method, you'll be declaring a bunch of variables. All right, so that's one type of variable that you'll see in a Java program. It's simply a variable that appears inside some method. Another example of a variable that we've encountered so far are parameters. Whenever you set up a method, one of the things you can do is you can give that method parameters. And parameters are another special type of variable that you can have in your program. But again, those are always created in association with some method that you're setting up. Okay, so what we're seeing here for the very first time is we're seeing examples of variables that we're declaring in our program, but these variables are not connected to any method. Instead, these variables are associated with the class itself, and any variables that we set up in this way, variables that are declared inside a class but not declared inside a method, these go by a different name. These are what are known as member variables. And we say that these variables are members of the class that we are creating. Right now, next, why do we have member variables and what do they do? Well, the whole purpose in setting up a class like this is a class is basically going to be representing what are known as objects. And what all objects do is they have data stored inside them. Right? Now, each time that you create a class, you'll be creating it for a specific purpose because you want to represent some entity that's of interest to you in your program. In this program, because we're dealing with a collection of points that are in the plane, that's our motivation for creating this point class. We basically want to create something that can stand for one of these points that we're working with that are scattered out throughout the plane. Right now, whenever you create one of these entities that's designed to represent something of interest in your program, the next natural question to ask is what kind of data should each one of these entities contain? Right? And in most applications, that question answers itself pretty quickly. For example, here, if we're going to create an entity that represents a point in the plane, two important details about points are their coordinates. Each point has both an x coordinate and a y coordinate. And that in turn motivates you to create these variables. These variables basically represent the data that is relevant inside inside each of these points. And each time you make a class for the purpose of representing some item in your program, you'll ask yourself, well, what data should this item contain? And that in turn leads to the creation of these so-called member variables. All right, so once we start working with these so-called point objects, we'll recognize that each point is basically a combination of two pieces of data. It's a combination of an X variable and a Y variable. And in a few minutes, we'll be seeing some mechanisms for accessing and working with those variables. All right, and finally, on the subject of member variables, one other thing which is different about these member variables is that as usual, when you declare a variable, you have to specify both a type and the name for the variable. We're doing that here. But in addition, member variables have one extra part. They have what's called an access specifier. And this access specifier can either be public or private. And as we'll see as we start getting deeper into examples, this will have consequences for how we can access and work with those member variables. In this example, both of these member variables are declared public, and in a minute we'll see what consequences that has. And then in a later example that we'll work with today, we'll see examples of member variables that are instead private, and we'll see what consequences that has. Okay, now, the only other thing you'll see going on in this example, besides the two member variables, is you'll see there's a method here. Right now, this is a special type of method. This is the first instance we've seen of this kind of method. This particular method is a special type of method called a constructor. And there's a couple of ways you can tell by looking that a method in a class is a constructor, because constructors have two very special characteristics. The first special characteristic is that constructors always have a name which exactly matches the name of the class that they appear inside. All right, so whenever you're looking at a class and you see a method whose name happens to match the name of the class, that's a signal that you're looking at one of these special constructor methods. The other thing that's special about constructors is, unlike every other method that we've seen, constructors do not have return types. And there's a good reason for this. This simply has to do with the way that constructors will actually end up being used in the program. But that's another special characteristic of constructors, is that they have no return types, and they also have no return statements in them either. Okay, now constructors in a class play a special role. The purpose of a constructor is basically to initialize the member variables. Right, and we're going to need a constructor in this example because we've set up member variables. Each point has both an X coordinate and a Y coordinate. And anytime you have member variables in a class, you're going to need to provide some way to give those member variables their initial values. And the mechanism for doing that is always a special method. It's a constructor method. Right, now, usually the way the constructor methods work is constructor methods take parameters, and the values that come in through these parameters will be used to initialize the member variables. Right, so as we'll see in a few minutes, when we create a point object, we're going to end up calling this constructor method. And at the instant we create the point object, we'll have to specify a couple of coordinates for it, an X coordinate and a Y coordinate. And those two values that I've specified will be coming in through these two parameters. Now, typically what we do in the constructor itself is we take whatever values came in through these parameters and we use them to initialize the member variables. Right, now, what we're seeing here in this example is another bit of special syntax that you'll see used in combination with objects. And this is a syntax that people frequently use in combination with member variables. And that is, when you want to refer to a member variable in an object, you frequently use a construct that looks like this. It starts with the special keyword this, there's a dot, and then there's the name of the member variable that you want to actually work with. All right, so here, when I say this.x, I'm referring to this member variable here, which is named x. All right, and more specifically, what I'm doing in this statement is I'm initializing that member variable. I'm giving it a value. I'm basically saying whatever value came in through this parameter, I want to assign that value to this member variable, and that finishes the work of giving that member variable a value. Right? And we do the same thing for the y variable, and at the end of this process, we will have set values for both the x and the y member variables. Right, so that's a very important role for constructor methods. They basically play the role of making sure that all of the member variables are properly initialized in your program. Okay, now, in a minute, we're going to see how you actually use a constructor. But before I transition to the code that shows that, let me ask if anybody has any questions at this point about either member variables or the constructor that I've set up here. Okay, now again, to get the full picture of how all of this works, we need to look at another piece of code. We need to look at a piece of code that actually makes use of this class. Because I'm going to be showing you some code that uses this class, but frequently we want to refer to this same class while we're talking about the other code, I'm going to do a little trick here. I'm going to split this off into a separate part of the window so we can look at both the description of the point class, which will be over here to the right, at the same time that we're looking at another piece of code that makes use of that point class. All right, so over here to the left, I'm going to open another piece of code, and this new piece of code is basically a new version of the closest points program. And the main change here is that I've rewritten the closest points program so that it now starts using this point class that I created a second ago. Okay, and this new version of the closest points program is going to have largely the same structure as the previous example. The only major difference here is I'm simply going to change the way that I organize the data in the application. All right, and that process starts right here with the method that is responsible for reading the data from the text file in the first place. All right, so that method is still called read points, and it will still be opening the same data file to read the data from it. The only difference is how it's going to be organizing the data when it actually reads it. Okay, now in the previous example, the way that data was organized is it was organized as a two-dimensional array. In this example, we're instead going to be switching to using a one-dimensional array. And in this example, we're going to be instead creating an array of objects. Since I have defined this point class, which we can use to represent a point in the plane, that now makes it possible for me to do something like this. I can now make an array of point objects. And if I have 1,000 points to work with, I can store all 1,000 of my points in this array. All right, and I'm going to be storing them specifically as point objects that are stored in that array. And then in turn, that's what this method will return. Once it's done reading all of the data for the 1,000 points, it will return an array of point objects to you. Okay, now, a very important thing to remember anytime you're creating an array is that the only thing that this step does is it creates the array, but it doesn't actually put anything into the array. That always requires a separate step that comes next. All right, so once we set up the array, the next step is to open the file so we can start reading data. And then because we have a lot of data to read, here's a loop that's going to be going down the lines of data in the file, reading the data and doing appropriate things with it. Okay, and for each iteration through this loop, we're going to be reading data for a single point. Initially, that will come to us in the form of a couple of doubles that we can read from the file. We'll read one double, that will be the x coordinate of the point. We'll read another double, that's the y coordinate of the point. And then the next step will be to create a point object from those two pieces of data. And then finally, we want to store that point object into the array. All right, well, here is one of the most important statements in this example. This is a statement that demonstrates the mechanics of how you actually take some data and turn that data into an object, and then how we can store that object into an array. All right, all of that action is taking place in this one statement here. Okay, now the first important thing in this statement is what's happening on the right-hand side of the assignment. What we see here is an example of what's called the new operation in Java. And the whole purpose of the new operation in Java is to create an object of some sort. And the way that you read this new operation is it always starts with the keyword new. What comes next is the name of the class of what type of object you're trying to create. And then what follows the name of the type of object you're creating is a set of parameters. Right? Now, the reason that we have parameters here is that besides making a new object, the other thing we're doing is we're calling a method. This looks exactly like a method call. It has a name, and inside parentheses, it has a couple of parameters. And the specific method that we're actually calling is this method right here. This is the constructor for point objects. And anytime you create a new point object, you have to call this constructor. And you have to give it whatever data you have available that it will use to initialize the X and Y values. And it will take whatever values you provided and put them inside the object. So now this object has an X coordinate and a Y coordinate based on the data that you've given it. Right, so that's how all of these things come together. They come together in this very important statement where we use the new operation to create a new object. And then as a side effect of doing the new operation, we're also calling this constructor method. And the purpose of the constructor method will be to make sure that the variables inside that object are set up correctly and they have the correct data values for that object. Right, and finally, the last step after making the object is we have to store it somewhere. In this case, we're going to store it directly inside the array in one of the spaces that's available in the array. And when this whole process is done, we will have created 1,000 different point objects for the 1,000 different points that we have, and all of that will be stored in a single array. Okay, so let me pause there and ask if anybody has any questions about anything going on in that method or anything related to the process of creating these objects. Okay, so now we have ourselves a collection of objects. After we're done calling this method will return an array of those objects to us, and we'll be ready to start doing useful work with the objects that are stored in that array. Right, now the next thing to take a look at is an example of a method that will make use of these objects. Right? Since one of the things we're trying to do here is we're trying to find the 2 points that are closest together. An essential step in doing that is being able to measure the distance between a couple of points. Right? So naturally, in our program, we're also going to need a distance method that will take a couple of points and answer the question, what is the distance between them? And the difference in this version of the program is that the distance method this time around is designed to work directly with point objects. Right, so here in setting up this method, I gave it a couple of parameters, and in this case, both of these parameters are going to be points. Right, so when we call this method, we're going to be passing a couple of point objects as parameters to it, and then this method is designed to receive those 2 objects and do calculations with them. Okay, now inside the method, when we need to compute the actual distance between the 2 objects, we're going to be using the standard distance formula. That's going to involve doing a square root and doing some calculations involving the X and Y coordinates of those points. Right now, in this example, you're going to see how we actually access the member variables that are stored inside an object. Since these point objects have 2 member variables inside of them, they have an X coordinate and a Y coordinate. This code demonstrates how you can reach inside the object and access those member variables. You do that by using a special dot notation. Right? So the way that you access a member variable in an object is you start by giving the name of a variable that has an object in it, and then to access the member variable inside the object, we'll use this dot notation. Right, so for example, to access the X coordinate of the point named 1, we use the syntax 1.x. And to access the X coordinate of object 2, we would instead 2.x. Right? And likewise, we can access the Y coordinates by using that dot notation as well. Right, so when you're writing a method that receives objects as its parameters, very frequently what you'll need to do is you'll need to reach inside those objects to access the member variables that are inside the objects. And the dot notation here shows how you actually accomplish that. All right, so now that we can get access to the X and the Y coordinates of the two separate objects, we can go ahead and do the distance calculation. And now the distance function is able to do what it needs to do. All right, so that's how you typically can reach inside an object and access the member variables. All right, now one final thing to say about this, this code where you can reach inside an object and access the member variables, there's another thing you have to worry about when you try to write code like this, and that is how the member variables themselves were set up. And in this example, when I set up the member variables, I was careful to declare both of these member variables public. Now, when you make a member variable public, that basically indicates that anybody who wants to can reach inside the object and access that member variable. That basically makes it legal for me to do something like this. All right, in fact, let me make a very quick change. Let me quickly show you what would happen if I instead declared one of these member variables to be private. All right, so I'll change that to be private, and I'll save that change. And almost instantly, as soon as I do that, any attempt to access that member variable gets flagged as an error. All right, and that's because I simply have changed what's called the access specifier for that member variable. And as soon as you make a member variable private, that then basically makes it illegal to access it in this way. All right, well, today, since we do want to be able to access the X and the Y variables by accessing them directly, the fix for that is to, again, switch this back to being public. Once that is public, then anybody who wants to has permission to reach inside the object and access that member variable directly. Okay, so again, brief pause. Any questions about the distance method and what I did in that method there?
Yeah, what would happen if you didn't declare the X and Y as public or private? Like normally,
Okay. Yeah, that's a worthwhile question to ask, because it turns out you can do that. You can declare a member variable without saying whether it's public or private. Right, so let me do that. Let me do that and save this and see what happens. Let's go back over here. Looks like nothing unusual happened. So it looks like the default behavior is if you don't say otherwise, probably by default, the thing is automatically public. Yeah, so that
okay.
demonstrates that you can actually leave off the public. And what appears to happen there is if you leave off the public is that the thing simply by default automatically becomes public. Okay, any other questions about the distance method or anything else here? Okay, now one final thing that we need to do with this example is we need to look at the main method, which is where everything is going to come together. And in the main method, this is where all of the logic of the application is going to be. And here's where we bring together all the pieces that we've constructed so far. Okay, so the first step is we have this method, read points, and when we call it, it will be returning an array of points to us. And of course, what we'll need to do is we'll need to store that array of points in an appropriate variable. So this statement reads the points, gives us an array of points, and then we're going to assign that array of points to this variable here. All right, then next, we dive into the actual logic of finding what are the points that are closest together. All right, and again, the starting point for this is to help us remember which 2 points were the best points we've seen so far. We're going to set up a couple of integers, and the purpose of these integers is that these will basically be locations in the points array where we have found a couple of points that are interesting to us. All right, and at the start of the process, the only 2 points we're going to look at are the first 2 points in the array, and those are found at locations 0 and 1. All right, and then the other thing that's relevant is as we're going along, we'll want to keep track of the shortest distance we've seen so far. And to start that process off, we're going to start by computing the distance between those 2 points by using the distance method, and then we'll store that as the shortest distance we've seen so far. All right, and then most of the rest of the work in the calculation here is in this nested loop. This loop is basically going to iterate over all possible pairs of points that we have in our array. And for each possible pair that we come to, what we're going to do is immediately compute the distance between those 2 points and then compare that to our shortest distance. If that is less than the shortest distance we've seen so far, we'll remember where those 2 points were in the array, and we'll record this as the new shortest distance that we found. All right, and the other thing to pay attention to in this example is that throughout the whole process, we're dealing exclusively in points because our array is an array that has a bunch of points in it. So anytime we reach into that array to access something in that array, that will be a point. So here, for example, we're getting a couple of points from the array and we're passing them to the distance method. And that makes sense because the distance method has a couple of parameters, which is a couple of points that we want to send to that method. All right, so that's, again, it's the same logic that we saw on Monday. The only difference is on Monday, we had all of our data stored in a 2-dimensional array. Now, instead, we have our data stored in a 1-dimensional array, and each item in the array is an object, which represents a single point. All right, and then the last thing to do is, after we've had a chance to look at every possible pair of points and we found the shortest possible distance, the last thing to do is to print the results. And for that, we just want to print information about where those points are located. And again, the way we'll print that information is we'll use the index values to go to a certain location in the array. And since the thing at that location is an object, we can access its member variable by using the dot notation. Right? So we use this notation first to go to one of the objects in the array, and then we use the dot notation to reach inside that object and get its x coordinate, so I can print that and show you where the point is actually located. Okay, so, and the last thing to do, as always, is to confirm that this actually works. For that, we just need to go ahead and run this program and see that it finds the same pair of points that it found on Monday. These are the 2 points in the data set that happen to be closest to each other, and it gives the same answer as before. Okay, so that is the end of this first example here. But before we leave this example, I want to do one last thing here. I want to demonstrate one last thing that you can do with classes. And for that, I'm going to go back over to the class over here, and I'm going to add one new feature to this class that wasn't there before. And this feature demonstrates another key thing that you can do with classes, and that is you can write additional methods in a class. All right, so I'm going to write an example of another method that would go into this class. And this is an ordinary method. It has a return type, and it has a name. In this case, the purpose of this name is, its purpose is essentially to print one of these points. Right now, what we're going to be doing in the code for this method is, since the purpose of this print method is to basically to print the coordinates of a point, all I'm going to do inside this method is to write a print statement. All right, I'm going to do system out.print, and we're going to have this print some text, which basically prints a structured form of what's in the point. All right, so we need to print a left parenthesis plus the x coordinate of the point, plus a comma to go between the 2 coordinates, and then plus the y coordinate, and then plus another parenthesis to mark the end of that point. Okay, so again, what I'm taking advantage of here is I'm taking advantage of the fact that when you write a method in a class, one of the things that those methods can do is they automatically can access the member variables. All right, and in fact, any method that you write that is in a class which has not been declared static, any of those methods have free access to the member variables, and they can use those member variables anytime they want to do something useful. In this case, what we're doing is we're simply printing those coordinates so we can get a description of the point. All right, now, another very important thing to point out about this method is up until this point, anytime that we have written methods in a class, those methods have always looked like this. They've always started with public static. All right, well, for the first time here, what we're seeing now are methods that are declared public, but they don't have the static part. And that's very significant here because as soon as you leave off the static in a method declaration, that basically gives that method permission to see and to work with the member variables. Right? Static variables, on the other hand, are not allowed to access the member variables. So anytime that you are writing a method that needs to get access to the member variables, you have to be very careful to leave off the static part in setting up and declaring the method. Right? So this is a new example of a new type of method that we're going to be writing. It's called a non-static or just an ordinary method in a class. And to demonstrate how you would actually use this method, let me rewrite the code in this other program here to show you how this method typically gets applied. Right now, the way that you're going to apply a non-static method is by first mentioning a point object and then calling the method on that point object. Right? And that looks something like this. Right? Let me first retype this code so that it makes use of methods instead. I have to restructure a little bit of this, like so. And make sure that we've got all of the, let's see, I think it's probably complaining because it wants the plus to be there. And oh yeah, we need another plus here because again, we're basically mixing together code and strings in all of this. All right, and I guess it's probably complaining again because I don't have that structured properly. Oh, okay. Sorry. Here's another aspect of how this works. To actually successfully use this method, we're going to have to slightly change the way that we do the printing. So I'm going to have to restructure that a little bit more. Because what we're going to be printing here is we're going to be printing a mix of text that we type out directly and text that comes from this method. We're going to have to slightly change the way that we handle all of the printing. So let me reorganize the printing a little bit more so we get all of that. All right, so let's do print. Okay. All right, and do that. And then let's do the print command over here for this object. And then finally, let's split off this last piece of text into its own print statement. Okay, so unfortunately, this gets a little bit more complicated. All right, and then here is the final piece of text that we want to have printed. Okay, now unfortunately, I had to do some extra code here because if you are basically going to be printing a mixture of text and stuff that comes from a method, we have to split it up instead this way. This has to be basically structured as a set of separate print statements. And we basically have to take turns printing text and letting the objects print text themselves. All right, so the first thing we do is we print the first part of the sentence, which is just straight text. Then we go to one of our two objects and we call the print method on that object. When we call that method, that will take us over here, which in turn will run this print statement, which prints the contents of the object. And then we need to print some more text, which is done by doing this. And then we need to tell the second object to print itself. And then finally, we need to wrap the whole thing up by printing some more text. All right, so that's about the only way to get these things to play nicely with each other. This basically has to be done as a series of separate steps, where in some steps we're just straight out printing text, and in other steps we're going to the objects and we're asking them to do some of the printing themselves. That's how all of this can come together and get us to successfully print the results. All right, and again, to check that this was working correctly, we just need to run the program and see that the output looks exactly the same as before. And it looks like I made one mistake here. We don't need that parenthesis because the object itself is going to be printing that parenthesis. And likewise, I don't even need this last parenthesis because, again, when I go to print that object, it will be printing that parenthesis itself. So that can go away. All right, so that fixes a couple of small glitches in the printing. So now when I run it again, it will be printing the correct information. Okay, so again, that's another significant example. That's an example of how you can add yet more methods to a class. And the purpose of these methods is to allow you to do useful things with the objects that you've created. So here what we've done is we've added a method that makes it possible for a point to print itself. And the way that you would invoke that method is by mentioning an object that you would like to have printed. And then to call that method on the object, you use the same dot notation that you would use to access the member variables. All right, so this introduces a new and very significant type of method. This is now simply called an ordinary method in an object or in a class. And the code here illustrates how you would invoke and call one of these ordinary methods. It always requires that you mention an object, and then after the dot, you mention the method that you would like to invoke on that object. Okay, so any questions about that? Okay, so I think at this point I've thrown enough new concepts at you. We've seen enough new ideas here. Today we've been introduced to member variables. We've had an introduction to constructors. We've seen an example of a program that makes use of collections of objects that are stored in an array. And I've given you your first introduction to ordinary methods inside a class, right? And that's a whole set of new concepts for you to wrap your head around. So my recommendation for what to do next is on the course website, I've posted a list of suggested reading from chapter 9. So I strongly suggest that at some point in the near future, you read through these sections. This will reinforce a lot of the ideas that I've shown you in this first example today. And again, since I've thrown a number of new concepts at you, you'll want to read about these concepts in the textbook to reinforce everything that I've told you here today. Okay, so that's a good point for us to stop today. When we come back on Monday, I'll be showing you another example where we create a class and start working with it. And we'll have an ongoing series of examples throughout next week where we're dealing with objects. And then also don't forget that the lab next week is still going to be focusing on arrays. We're going to have a lab that focuses on two-dimensional arrays. And we won't have an object lab until the week after next, but eventually we'll start working with objects both in our assignments and in our labs. All right, and one final comment before we go is that up until this point, my practice has been to give you a programming exercise every Friday. I'm going to hold off on giving your next programming exercise. On Monday, I'm going to show another example related to the basics of objects. And then after the lecture on Monday, I'll be giving you a programming exercise then that will be due on Friday of next week, right? So this week, no programming exercise over the weekend. That instead will be assigned on Monday, and that will be due on Friday of next week. All right, so until then, everybody have a good weekend. And over the weekend, hopefully on Saturday, I will have the midterms graded and sent back to you. And also tomorrow, I'm going to be trying to grade your work for lab number 5, and I'll be sending that back to you tomorrow as well. All right, so have a good weekend, everybody, and we'll see you all back again on Monday.
Thank you.
Thank you.
Thank you.
Bye-bye, everybody.